or that's the goal. The vision is end to end. We're not quite there yet, but we have a lot of capabilities already started and built into the toolkit to kind of automate the process of trying things out very fast, like trying in Redshift very fast. So the agenda will be as follows. I'll just kind of quickly summarize Amazon Redshift. I'm not going to go into a lot of depth. That's not the focus of today's meeting, but I'll just do a high level summary of Redshift and a few other analytics offerings we have at AWS. And then also I'll just briefly go into what are the challenges that we see sometimes when you're trying to just put all this together and start up this stack manually, right? And some of you, I'm sure, are aware of these, but just kind of briefly go over those. And that was the impetus for us developing this, this toolkit to kind of make that whole process easier of provisioning an analytics stack and migrating your data and starting to just use it and test it out. And I'll just wrap up with like a short demo at the end. And of course, if we have time, welcome questions throughout the presentation. Feel free to interrupt me anytime. I don't mind. Or we can hold some time at the end as well. All right. So let's just get again high level. I'll just talk about Amazon Redshift. AWS is putting a lot of investment in analytics overall. It's a huge focus for AWS. So there's been tons of a barrage of feature enhancements, not only to Amazon Redshift but to the whole all the analytics services, but especially Amazon Redshift. There's been so many feature additions and enhancements in terms of performance, in terms of ease of use, in terms of automation, right? And so that is really going to benefit you all as customers. You will now get with Amazon Redshift the fastest, best price of performance cloud data warehouse. We've done benchmarks that show that we're 3x better for price of performance than any other cloud data warehouse. There's been not only that, there's been, like I said, a lot of automation to help manage the offering, the service. Whereas things were like manual before, things like tuning tables and all that can still be done manually, but there's a lot of automation built into Redshift itself that does a lot of that automatically. So you don't have to worry about like what's under the hood or tuning tables and worrying about distribution keys and sort keys and all that. That those days are going to be, it's still here, but it's going to be less and less as we go along. And a lot of that will be managed inside the service itself. And it's also great. One of the best things about Redshift is you can analyze all your data. It's heavily integrated with so many other AWS services, like many AWS offerings, right? So, but with Amazon Redshift, you have the lake house approach. We're calling it data lake or modern data architecture. So you can run your data warehouse in Redshift, but then you easily integrate that and tie that and plug that into a bunch of other services around it, like the data lake in S3, like Athena, which is a serverless querying tool, like Glue, which is a cloud native ETL tool and catalog, universal data lake catalog, as well as ETL jobs. And the nice thing is, again, they're all integrated together, very, very seamless, context switching between these. It goes on and on. So that's where we're going with Amazon Redshift. Again, so many new features that have been added lately. I'll just name a few, like data sharing, like Aqua for boosting query performance up to 10x, like machine learning, SQL with SQL. So some of you may have heard of Amazon SageMaker. That's still there, but for lightweight machine learning or machine learning for non-data scientists, you can actually just do that with SQL with Redshift now. So it's really nice. So a lot of these services and features added, and much more to come. So this is a brief, architecture diagram of kind of illustrates what I just was talking about. So you have, Redshift at the center, but then, it can analyze and get insights on multiple data sources, data that's inside Redshift itself. Should you choose to, load it locally for example, like, your really hot data that you have very stringent SLAs on for your dashboards. You want that fast performance. At the same time, you can get pretty fast performance on the data lake, and then it scales out to hundreds of terabytes, even petabytes. And if it's structured properly and partitioned right, you can get, like I said, really good performance there as well. And lastly, I want to just bring up a new feature called federated query. With Redshift, you can analyze data on your transactional systems. Right now, we offer that with like Postgres and MySQL. And so you can, should you have a need for like drill down capabilities on your dashboards, for example, the data is not necessarily all in Redshift, but it's at the transactional layer. No problem. You can actually use the same SQL to join local Redshift tables with tables on Postgres or MySQL. And then of course with the other side, the consumer side, you have the BI tools. Amazon offers QuickSight. We're eventually going to probably wrap that into this whole toolkit. It's not there yet, but it's definitely on the roadmap. And of course, a lot of other BI tools like Tableau and many others, they integrate very, very well with Redshift. And then we have a really nice, pretty new query editor built right into the Redshift console. It's called V2 editor. It's very, very powerful. And there's third-party tools, which I'm going to talk about, like Apache JMeter. It's a very powerful load testing tool from Apache. It's open source. Those are the services that can really help do load testing on Redshift. And again, there's been challenges with provisioning that, but that's where the toolkit comes in. Lastly, on the left side, AWS, we have migration services like data migration service and also schema conversion tool. They make it very easy to quickly migrate data, capture data, move it one time into Redshift from other data sources within AWS or outside on-prem, from Oracle, SQL Server, many other RDBMS offerings. We have data migration service easily can integrate with those and migrate your data into Redshift, both one time as well as change it and capture. All right. Now, all the things I said sound great, but if you're putting it all together from scratch and just doing it, taking a manual approach, it can take a lot of time. There's issues with that, right? We conduct POCs with customers, and sometimes we used to actually just watch their console and kind of talk them through the steps, and it takes a lot of time. Creating a VPC from scratch, creating a Redshift cluster from scratch, and one at a time, creating a DMS instance, creating an SAT, all that, right? It takes a lot of time. Not only that, when you end up creating them all and you got to tie them together, right? You have to establish communication between them. You end up, we're all humans. We make errors, we miss things, we maybe misconfigure a security group, and we have to troubleshoot those, and that can cause more delays and whatnot. Lastly, what's often missed if you do this manually is the best practices. We all want to kind of do things quick and get it up and running, and so you may just we've all probably done it. You may kind of take shortcuts and open up your security group a little bit more than it should be open, right? And not taking the best approach of like minimal privilege, least privilege approach, both with like network access as well as with your users. So these are the challenges that we've kind of seen and took note with taking a manual approach in provisioning not only analytics, but everything in Redshift or everything in AWS. But in terms of analytics, so we actually took the initiative, and as is the charter of our team, to help customers do this very fast and quickly and with the least amount of pain and incorporating those best practices. So that's where the analytics automation toolkit comes in, AAA. This is a way to quickly, end-to-end provision all the things that I talked about, especially the things that you see in this diagram here, Redshift, as well as like a VPC, as well as the migration services we talked about, DMS, SCT, and even Apache JMeter, which is a new recent addition we added to the toolkit. This is now provisioned all automatically with this toolkit. So if you want to just kick the tires and get up and running and quickly try it out, you can use this toolkit to do all that. Now, it uses infrastructure as code. We don't use cloud formation, and the reason for that is we wanted to make this flexible. Not everyone wants to do the same thing, right? Some customers they have a lot of AWS services already provisioned. Maybe they have some applications or EC2 instances or something, already provisioned in a VPC, right? And they want to use that VPC. So, or some other customers, they don't care about JMeter. They just need data migration service and, migrate it, or vice versa, right? So we wanted to make this framework flexible enough that, you can choose what you want. You can use an existing VPC, or you can create a new VPC, use it to create a new VPC. You can choose to, provision DMS, or you can say, no, I don't want DMS, I want JMeter, or I want them all, right? So we use this framework called CDK, Cloud Development Kit. It's pretty neat. You don't have to worry about it. If some of you used it, great. If you haven't, no problem. You don't have to mess with that, but that's just to let you know that's what's under the hood. That's what it's coded in. It's all in GitHub, the project in GitHub, and the instructions are very simple to to actually launch it, so you don't have to mess around with the code at all. It's just a simple configuration file you need to prepare in the very beginning, and even that we're going to try to abstract that, and we'll actually try to make a web interface instead. But right now, you do have to take a text file, download it, and prepare that with the inputs. For example, I'll just show you what that looks like. This is a configuration file. This is what it looks like now. The top level is just the whole and dictates what the services you want. Like I want a VPC, or no, I don't want a VPC. I'm going to use the existing VPC. Put that ID here. For Redshift, you say create, or you can even put in an existing Redshift cluster, right? So the instructions for this are all in a blog, which I'll share with you. But this is what that file looks like, and for each service that you indicate you want to create, you just simply put some details about that in the section below. We won't go too much into detail on that, but the blog goes into great detail. But that's just to let you know this is what needs to be prepared in the beginning. And once you do that, it's very easy. Just a few steps, which I'll show you to launch the toolkit. All right, and again, the advantage of this is once you do that file, you just open Cloud Shell, and I'll show you that, and launch it, and everything else gets provisioned under the hood, and all these services get provisioned and integrated, automatically. So the security groups all created for you, VPC created for you if that's what you want, and again, using best practices, we don't open up the groups to internet. We just we take your on-prem CIDR block, and we just make a security group just for that. All right. Any questions so far? Let's take a quick pause before I move on. We'll get to the demo very shortly. Okay, great. Now, the nice thing about our recent enhancement we did is this JMeter tool, which I'll show you in a second. But it's a really nice tool. It's very robust. Has a lot of capabilities to do powerful load testing on many databases, including Redshift. It has a lot of capabilities. I'm not going to go into detail of all those capabilities are, but the nice thing is there's no coding needed. It's all GUI based. It's a Java tool, and you can create very, if needed, a complex load test with many different inputs, like as far as SQLs and load, even load commands like copy commands, and you can even make them into different groups using different users if you want. If you have, like, for example, Redshift has workload management. You can assign different queues to different users. So if that's what you did and you want to test that, it's very easy to conduct or configure a test with different users launching different SQL. For example, you can have an ETL user launching like ETL loads, like DML statements, or stored procedures or data loads. then you have another user running BI, right? So just that's a read-only BI queries. So you can set those into different groups, even using different users to log into Redshift, and of course, different concurrency levels. So it's very powerful. Now, the downside, or not a downside, I would say, but the deterrent would be like to set this up from scratch, especially if you haven't used it before. You have to go download, JMeter. You have to install it. You have to then get some independence. You have to download those like Java and maybe so other things like plugins if they're needed. And after that, you have to create a whole test plan, and that can be. It's not that extremely difficult, but it can be like a deterrent. So with the toolkit now, all that's gone. You don't have to do any of this. The downloads are done for you. The plugins are downloaded, installed for you. And the test plan, a default test plan is auto configured for you. And so, and obviously that may need customization. It probably will if you're testing on your data. But that's very easy to do. Everything's there, and it's so easy to kind of see, okay, this is a SQL. I want to change my SQL, and I want to change the concurrency. So, and finally, the toolkit also, if you wanted to just test out Redshift in general, and even JMeter in general, you don't necessarily have your data set ready. You can even use the toolkit to load sample data from TPCH benchmark. And in fact, the sample test plan, which I just mentioned, it's configured to run against that sample data. So you have SQLs and everything right there, and I'll show you that. If you don't want to use that, if you want to use your data, which we encourage, obviously that you just simply load your data to Redshift, and then you adjust the queries to match your data and your workload. All right, I am going to now switch to the demo and kind of show you this live to an extent. I've already kind of run it, but I'll just kind of show you how you do it. And again, I will show you a blog at the end, which goes into the steps in detail. So the way you start this toolkit is the first thing you do is, I don't know if any of you use Cloud Shell. It's just a simple terminal that you can launch from the console itself. So that's how we use this. So it's very easy. You just go into services and pick Cloud Shell, right? And that's what I did. And so once you're there, and all this is again in a blog, and I'll just show you the blog real quick. There, let's see. Here we go. This is the blog, and I'll share the URL with you. That goes into the steps in detail and instructions step by step, including preparation of the configuration file, right? And all the steps to kind of start running it. So the commands you use to run the toolkit are in this other blog here, and it's right there. So it's there. I can copy it here. I already ran this. So I'm just going to search my history. So it's just there. You copy this, clone this command. It just basically clones the Git project down to this Cloud Shell, and then you just run one more command. It's a deploy command. It runs a script in there, and that's it. So after you do that, you will be prompted for a few things. You'll be asked to upload the config file we just talked about, and you do that like as follows: you upload file, and you just find that file on your laptop, right? And that's, like I said, it's a prerequisite. You go and do that. And once you do that, then you supply the config file, and that's it. That's all. Then you're done with Cloud Shell, and all the services will be provisioned for you. And it takes about, I would say 20 to 30 minutes. But everything gets provisioned and integrated. That's the key thing. And I'll show you that real quick. You can see those services in CloudFormation. It does actually use CloudFormation, behind the scenes, but this CDK is sort of a programming language, interface on top of CloudFormation. So at the end, you'll see that it created all these stacks. One is for the VPC, one is for Redshift, one is for JMeter, and so on and so forth. But if I had chosen, I think I didn't do DMS in this case, but if I chose that, it will have created DMS, and that's a big deal because DMS takes some, I'll just show you real quick. It takes some, steps to go through it. You have to provision, first of all, like a DMS instance, right? Which is replication instance. That's where all the work is done by DMS. And then you have to go and create endpoints, right? And you have to create, after you're done with the endpoints, like for your source database, like on-prem, and then your target database, so Redshift, then you create tasks, right? That use the endpoints and puts it all together. So it's a lot of steps. The Toolkit does all of that for you. You just you take the config file and you put the information on your external database. For example, if it's Oracle or whatever SQL Server, you put that information here. You put the host information and then the user and all and so on and so forth. And it'll create all that task for you. And then you simply, when it's done, you simply log in and you run the task. I am going to now just show you real quick the JMeter part. So let me go to EC2. So what the toolkit did in the one I just ran, it created this EC2 instance. It's a Windows instance. And that is where it auto-installed JMeter, right? That's all here. I can see that after it's done, and it'll have my the host name, right? So once you get the host name, you can use RDS and install Microsoft Remote Desktop. Excuse me, not RDS, Remote Desktop, and then you can just go ahead and log into that host, right? And I just put that host in here, the host name, and then you log in, and you'll have to supply a security key. So I already did that, but you can do that here behind the scenes. Actually, you get the security key to get the Windows password. That's what I had already done. I supplied that here, and I used Remote Desktop to log to the EC2 instance, and that's here. So here, you can see the JMeter is already installed, and I had this icon on the desktop here, and I just simply clicked on the icon, and JMeter is up and running. So a lot of other work was done for you. It's downloaded, it's installed. Java was also downloaded, installed. There's also a plugin for JMeter, which was already installed. Not only that, like I said, the test plan. Normally, if you launch JMeter, you won't have anything here. Like you have to start from scratch. So you go ahead and just file, edit, create a new test plan and all that, right? So all that's done. And the blog goes through steps that you need to do to obviously make some modifications. Of course, the first being supply your Redshift Connect endpoint information. So that will go here in the top level, like a JDB connection. And of course, I pulled that from the Redshift console over back here. That's easy to find once you create that cluster, which is the toolkit created it. And on the cluster front page, you just pick the endpoint, the JDBC URL. I copied that here and I put that back into JMeter in the database URL. And the driver is already there. You don't have to mess with that. Then you supply a user that you want to use for the load test, and that was done here. And you supply the password there too as well. And then after that is where you basically just can skip right to the fun part, which is the test itself. What does the test do? What do I want to test, right? And like I said, in the default or the sample test plan, we have created this, done a lot of this, work for you. What we did is create 3 what's called test groups or thread groups. We created 3 of them, and you may not need 3 for your test. You can, maybe you want more than 3, right? Or maybe you want 3, right? Either one. So no problem if you don't want this many. You just delete these thread groups. It's very easy, right? You disable them. And you can maybe say like, okay, I want 3 groups. It's fine, but I want to test my own data. No problem. You just go into each group here. I won't go into detail of JMeter, right? There's a whole, JMeter is a whole nother discussion, but I'll just give you like the high level, easy, quick start points. You just take, and under each group is a SQL entity. which is the JDBC request that's sent for under each thread group. So you just change the SQL to whatever you want. It will match your data. This SQLs I put in all each group. They actually are working against the TPC DS. Excuse me, it's a DS data set, sample data set, which I used the toolkit to load into my Redshift cluster automatically. So you'll work with that. And it's just 3 different SQLs: small, medium, large. This one runs in like a few seconds. This one takes like, I don't know, 30 seconds. This one takes a couple minutes. And lastly, for each, and this is a really powerful thing with JMeter and this plugin we used, also we auto installed, you can adjust the concurrency for each thread group independently, however you want. So you do that as follows. In this one, I made it very small because my cluster is kind of small. I don't want to overload it, but I just chose to run this thread group five threads, which mean 5 sessions were logged into Redshift. And I have initial delay 0, which means as soon as I start the test, the threads start logging in. Sessions start logging in. It will log in over a period designated here by the startup time, which is 30 seconds. And then once they're all logged in, they will hold for this amount of time, which you specify, which is in this case, it's like 5 minutes, 300 seconds. And then it will lastly, after that whole duration, it will shut down over a period of 10 seconds. So now it's very powerful because you can add, so many rows to this. You can say, okay, after the first initial 5, I want to have another 15. And, I want to have them, delayed, I want to have them, initial delay at like 20 seconds. So let these 5 log in first and then, wait, whatever, however much longer, wait 30 seconds and then start loading more, like 15 or something, whatever you want. So this graph comes up, that will depict that thread schedule for this specific thread. So it's very powerful. So you can do as much as you want or as little as you want, and it's all kind of easy to do, easy to follow using the JMeter tool. So lastly, I'll just kind of just go ahead and show you this in action. I'm just going to start this test to just work and with my data set. Like I said, because I loaded the TPCDS data set, and these queries are designed to work with that. And you can see the sessions are starting to run by this little icon in the top here, and I can have a log of that at the bottom as well. You see the threads have started to run. Running these different queries. So let me go back to the Redshift console, and I can show you how you can monitor that a little bit in the AWS console. So here I'm in the screen with my cluster selected, and I might not see any CPU utilization yet because it takes a minute to kick in. Yeah, there's nothing there yet, but I should see the queries if I go to the query monitoring tab. If I scroll down here, I do see some queries running now. You see. So my test is running. So that's how easy it is to, load test with JMeter. And again, very powerful and large scale load tests. You can scale this out. You can run dozens of concurrent users. You can run hundreds if you have if you have big enough cluster to handle that. And so this is my queries running, and you can use this to, again, test the queries and kick the tires on Redshift, test the performance of Redshift. You can also use it to test features in Redshift. For example, in the blog, maybe I'll just switch over there. Let's go to the JMeter blog. Here's right here. Yeah. So in the blog, I show how I use this to run a load test. So what I did is this is stuff I just all went through it all already. Okay, so what I did in the blog case is I kind of tested out the impact of a feature called Redshift called concurrency scaling. In case you don't know what concurrency scaling is, it's a very powerful performance feature of Redshift. What it does is monitor the queues of your Redshift cluster. And if your queuing level goes over a certain threshold, which you can control, then Redshift will auto provision what's called a burst cluster. So basically what it will do is double, effectively double or even more. You can do triple, quadruple the capacity of your cluster. And it takes like only seconds or like a minute to kick in. And so in case your workload of your data warehouse has like, a burst of activity, at the month end or each week or each night or whatever, the slew of BI users coming in or a huge ETL workload kicking in, this concurrency scaling can be configured to start and provision that burst cluster on the fly in just a minute, right? And so I have illustrated the impact of with and without concurrency scaling in this test that's conducted and documented in the blog. So your first test here, you see the duration of my CPU shot up and then shot down. This is with concurrency scaling. And the second one was without. I turned it off. You see how much longer the test took to run. So you can use the toolkit, again, to test features like this, like concurrency scaling. Just to show you that, illustrating that here. Let me zoom in a little bit. This is, I was telling you about the queuing, right? So Redshift, if it doesn't have enough resources, it will to service all the statements and the queries coming in from the different users. It will manage that by queuing them, putting them into queues. So and that's depicted in this slide, and this is all in the console, which I just showed you. You can see this here in the console, workload concurrency. So those are snapshots from the console I took. And so in this test I ran before, you can see concurrency scaling was on here. I only had the blue graphs. I'm sorry, it's probably hard to see, but the blue color here depicts queuing. So those amount of queries were queued, right? And it's like the number is here somewhere, whatever. It's like 10 or so. This is a big test. I ran like 100 of concurrent sessions. But you can see that it was only for like the first couple of minutes. After 2 minutes, concurrency scaling kicked in, and boom, there's no queuing at all. Everything just kind of went through and was serviced by the cluster resources, thanks to the concurrency scaling. And in contrast, in the second test I ran without concurrency scaling, you could see how much queuing there was, right? It took a long time. These users were just kind of waiting and queued, and had to wait for the queue to clear to get serviced. And lastly, I'll just show you the real impact for the users. It's depicted in this graph. I just took the results from JMeter. It will actually generate a bunch of CSV files for you, both aggregated files like summaries for each thread group, like summaries, for example, like average runtime for each thread. You'll have those, and you'll also have a detailed run per session, all the full data per session, how much each query ran per thread. But I went ahead and graphed that, again, with and without concurrency scaling. You could see the performance of average query performance for each thread, large and medium and small, with and without concurrency scaling. You can see it's like night and day. Like look at this small query with concurrency scaling was average like 9 seconds. And this was again with a slew of users hitting the system, right? And still, it only took 9 seconds. With concurrency scaling, without, it took so much longer. All right. So again, that's in conclusion, this whole toolkit, including the JMeter edition, can be used to test out Redshift, to kick the tires, especially test Redshift features like concurrency scaling, like other features as well, like Aqua. It's a really new, neat feature to accelerate analytic queries. You can test different sizes of clusters as well. I can run the JMeter with my base cluster, but maybe I'm looking at optimizing my cluster price performance. Maybe I don't want to spend that much money. I want to see if I can shrink down the cluster size and see what it's going to do to my concurrency and my workload. So you can easily do that in this using this Toolkit, you run the baseline, configuration, like I just walked you through. Use AAA to configure everything and provision everything. Run your JMeter, and then you can go here, and just say resize. Say, okay, I want to try, to, see how this looks with a smaller cluster. Like, so I have, 8 in mind, but I don't want to try. I'm trying with more. I want to try with less. Right. So you just make that change here and resize it. It takes just a few minutes to resize, and you rerun your test. I think it's pretty much most of what I wanted to go through. We have about like 10 minutes left. I believe I'm done with what I want to go through. Yeah. So the last slide I have is like, this toolkit will let you to, load test pretty much with a click of a button if you want. And like I said, that sample data's loaded already because I chose to load that, and that is simply a option in my configuration file. Under the Redshift section, I have there's a option to say load TPC data, yes or no. And I chose yes, and so it loaded it. And so that's what I tested. But if you don't want to do that, you want to load your own data, no problem. You just say no here. You load your own data and test your own data. I'll stop there, and happy to take questions.
I think it's pretty cool that one thing I just simply did not realize JMeter offered was the ability to actually load test databases. That's pretty slick. Given that the solution's built with the CDK, I mean, it'd be quite possible to even build a pipeline, right, to where you can, kind of have a best guess starting point for how you configure Redshift, run the tests, and then based on the result of the load tests, tear it down, try something new, and run, right? I mean, that's sort of the idea, right? Okay.
Yeah. In fact, that's on the roadmap. We are planning to integrate this toolkit with another tool called Node Config. That's one based more in cloud formation, and that kind of does what you just said, but it doesn't have the whole stack. It doesn't have like DMS and all these other things. So, but it will take inputs like different cluster sizes you wanted to try. So you can, like, similar to the inputs in this file. And in that, once it's integrated, we'll all put it in one. But in here, you can, like here, I put my cluster size, right? I put, RA3 4X large, 12 nodes. Once we add that on, we can actually put multiple sizes. You can say, okay, 12 nodes, 8 nodes, 6 nodes, 16 nodes. And what it will do is, as you said, test all of them and spit out a summary report that compares the performance from all the different configurations, and you can kind of choose very quickly what's your optimal configuration and compare with your price, how much you want to spend. So that's coming.
That's awesome.
Hopefully,
yeah, there's
a few months. Yep.
Yeah, very cool. Thank you.
Sure, no problem. Anything else? Anyone? Hope this was helpful. It was beneficial. Anyone interested in Redshift, or anyone already using Redshift?
Hey, Samir, one question as far as like the intended use case for this. So do we see this as something that customers would use like anytime there's a change in the requirements for Redshift, or changes in expected performance or new features they want to try out, or when do we see customers using this?
That's a good question. The primary impetus for developing this was new customers looking to try out Redshift, so like doing a POC. That's, I would say, the primary use case we had in mind. But it can certainly, be used for other things. Like you said, with the new feature of Redshift comes out, I don't want to go ahead and turn that on in my existing production cluster. I want to just create a temporary test cluster, and I can use this toolkit to do that. That's totally a fit. And I can try out the new feature. Yeah. Mm-hmm.
All right, thank you.
Sure.
You'd asked a question about usage of Redshift. So we had a I'd say some somewhat simplistic use case for Redshift where we were basically doing like flat file loads for some data analytics.
Okay.
Ultimately, though, we were kind of shifting direction more towards kind of a pure serverless approach with Athena,
Athena.
possibly looking at something like Spectrum in the future.
Sure. Yeah. Yeah, that's great. Yeah, Athena's great. It's the quickest way to start some analytics. You don't need any server. Just a heads up. Redshift you have to provision, right? But it's really self-managing. Like you don't have to manage those nodes. Also, what has just been announced, it's not in GA yet, but it's in preview, is serverless Redshift. So that is also available now in preview. In case it's of interest,
that's right.
and that will just have more capabilities. Yeah. Mm-hmm.
Yeah, that's a good call. So there it may warrant, and I'd imagine like I remember the announcement. I don't remember the specifics of say like what you would say provision, right? And I'm sure there's something around concurrency or something like that, right?
Yeah.
It may warrant further investigation in determining what has maybe the best price per performance for our specific use case.
Yeah. The nice thing about serverless is it will be a lot better, I think, for certain use cases or certain workloads. With provisioned, one of the downsides of provisioned is it's when it's up and running, you're paying for it, right? You can pause it, right? You can pause it and you can resize it, so you can change that. You have dials to make it smaller, bigger, or even turn it off to stop paying. Those are largely manual with provision. With serverless, they completely become automated. So you don't have any really servers. You do have this unit called RPUs, Redshift Performance Units. There's a default one. You can just take the default, but it will automatically go up and down depending on your workload. And the nice thing is, it doesn't even you don't even pay. You don't pay at all unless somebody is running something. If somebody is loading some data or something is running a query, only then you pay for serverless. If nobody's running anything, you don't pay anything. So if you have an intermittent workload that's very sporadic, and maybe on the weekends there's nothing going on, and even the weeknights or whatever, serverless could be a really good option to have a much lower price for the same performance and capabilities.
Absolutely. I mean, and one of the things I often run into, and it was sort of explained really well by someone a few years ago, is Redshift's sweet spot. I'm going to kind of butcher what I heard, but it's when you start entering, I think like the terabyte range, right? In terms of data, there's obviously more nuances to it than that. But what we often run into is customers who feel that they have sort of a data warehouse type use case where reality it's just they want to stick a few hundred gigabytes of data somewhere and more or less do visualizations or reports on it. So something like this is probably a great tool to really demonstrate at that scale, kind of on the lower end of the spectrum, if you will. There's other performance considerations you may have.
Yes, I agree. You can even go use this tool for larger use cases too. But yeah, you're right. It's more for like I said, kind of trying things out, and POCs and stuff. But yeah, data migration is pretty powerful. I don't know if anyone's used it, but it's really, really powerful tool. It's very easy to use, and this makes it even easier to move data from another like on-prem source. All right. Anybody else?
Yeah, no, I mean, No, for me, this has been really awesome and informative. So I appreciate both personally and for the user groups you taking the time to walk us through this tonight. It's super exciting.
My pleasure. Great to talk to all of you. And if there's nothing further, any other questions, I'll just hand it back to you, Patrick.
Great. Well, yeah, that's it for me as well. Again, thank you so much, Samir, for sharing. If you want to either share the link to the blog and or the presentation, I could go ahead. I'll get that posted out to the meetup sites, as well as the recording as well. But thank you again for volunteering and sharing this with us. And I think there's going to be a lot of value, for the community and not only understanding how they can, sort of infrastructure as code stand up, really a full pipeline, including Redshift, but also load test it as well.
Exactly. Yep. We'll do. I'll send you this information, and yeah, that'll be great if you can forward it on. Appreciate it.
Great. Thank you. And thanks everyone for joining us tonight.
Thank you and good night.
Take care.
Right, take care.
Bye.
Thank you.